So, as always,
Is that right?
what we're going to do is we're going to try to break this down a little bit. And we're going to start by making observations about the first one. Okay? So just the first one, number one. All right, tell me make some observations. Okay?
Acceleration is constant.
I actually think that's a great observation. Okay? I actually think that's a great observation. If you look at any of these boards, I think you all did something very similar. Okay? I think you all did something similar where I agree with that. What makes you think that the acceleration should be constant?
Because all the acceleration arrows.
Well, that's how you represented it, but why did you represent it that way?
Because you're pushing it with the ruler.
Yeah, oh gosh. I agree with that. I think that if you pushed it with the ruler at the same constant force, would that lead to the same constant acceleration?
Yeah.
Okay, seems reasonable. What else do you notice about the first one? Okay, you don't have to infer any meaning. I just want you to tell me, what do you notice?
Yeah, the dots get farther apart.
Good, dots get farther apart. What else?
Velocity arrows get longer.
Good, velocity arrows get longer.
Yeah.
Absolutely.
To the right, or accelerating to the right.
They're both.
Yeah, so I want to highlight what Mar said, because she didn't enunciate, because she's hiding behind her board. But no, she said something really interesting. She said, if you notice, both the acceleration and velocity arrows are in the same direction. Do you guys notice that?
Yeah.
All right, do you guys remember the velocity dance?
No.
Did we do the velocity dance in here?
No.
No.
Are you sure?
I'm 100% positive. You think I wouldn't have been doing it this whole time?
You think if there was a dance, we wouldn't have been doing it? Maybe I didn't call it that, but that's what it's called. All right, so take your right hand. This is your velocity finger. Left hand, acceleration finger. Everyone, come on, fingers up. Okay.
My side.
Okay, buddy.
And the camera's at me. Like,
All right, here, I'll move it.
Yay!
Is that better?
much better.
All right, so if they're in the same direction, velocity and acceleration are the same direction, what's your object doing? Is either speeding up or slowing down?
Accelerating, speeding up.
Well, okay, so when you say accelerating, do you mean our physics definition of accelerating or our everyday definition of accelerating?
Everyday.
Okay.
Aren't they the same definition?
They are not, actually. So this is something that's important, okay? When we say accelerating in our everyday life, we just mean speeding up,
Yes.
okay? So for example, in your car, what is the pedal that's on the far right called? It's called the gas pedal. It's also
The acceleration.
called the accelerator. Because if you press on that, your car should speed up. But
You can also press it down when you're going. You have to hold it when you're going at a constant speed.
that is true. So if you're going fast enough, but if you want your car to speed up, that's the one you press.
Yeah.
Now, so our everyday definition of acceleration just means speeding up, but our physics definition of acceleration is any change in velocity. So it could be speeding up or slowing down. Right? Back to the fingers. Are you ready? So put them up, both up. Are you speeding up or slowing down? This is speeding up. Ready? Watch the next one. Do it with me.
Slowing it.
What's this?
No, I don't know.
Speeding up.
Also speeding up.
I lied. Speeding up.
Oh, this is speeding.
They're in the same direction.
Because our rule is,
We definitely know this.
if velocity and acceleration are in the same direction, what are you doing?
Accelerating.
Speeding up.
Okay.
Okay, so let's do it again. What's this?
Speeding up.
Speeding up. What's this?
Speeding up. Speeding up. Speeding up. Speeding up. Speeding up.
Slowing down.
Good. And this one?
Slowing down.
Also slowing down.
This makes so much sense now.
I'm glad. Okay?
Correlation, it doesn't work.
That's right. So if velocity and acceleration are in the same direction, you are speeding up. It works for this way too, like sideways
Speeding up.
or other sideways. And this,
Slowing down.
and this.
Slowing down.
Can't do it that way. Yeah. All right. So back to number one. What do you notice about the directions of your arrows?
They're in the
I
same.
forgot.
And your object is
Speeding up.
speeding up. Observations for number two, please.
They're in
Slowing down.
opposite directions.
So they're slowing down.
That's the whole point of today's lesson. Just hold on to it. Hold on to it. Thank you, Charlie. Oh my gosh, this is like the fourth time I've hit it. Charlie, show me. Good. What's it doing?
Slowing down.
Slowing down, right?
Because they're opposite direction.
because they're in the opposite direction.
Yeah.
Okay?
Dots are getting
Feel good about that?
together.
Good. Dots are getting closer together. Arrows are getting smaller. Velocity acceleration are in the opposite direction.
C.
Cool?
Yes.
Feel great about that. One of the reasons that we do an activity like this right now is that this is stuff that we've already talked about before, but it's really nice to solidify some understanding of something if you revisit it in a new context later on. Right? So Sahid was a good example of this where he's like, oh, that's what that meant? That makes so much sense to me now, right? Which is a great way to learn something, is to look at it in a new context and be like, yeah, that makes sense. All right. What about the third one? Okay. What are some observations of the third one you can make?
It's constant.
Until, well, then it gets.
Until it's pushed, and then it's pushed, and then it's constant again.
It's
Okay.
going faster, but it's.
So there's a couple things. Let's digest them all. Okay. The first one says it was going constant at first until it was kicked, and then it's going constant after that. That's what she said.
Oh, faster.
Okay. Is that true?
I
Yeah,
mean, yeah.
I hope it is.
All right. Is that what you guys have represented on your board here?
I believe so, actually. Maybe. What is it, number 3?
Yeah.
I think we said it was speeding up after it got hit.
Now,
No, that don't look like it's being wrong.
That was, it's like, it's marginal speeds, right?
Well, the unbalanced
It's
force was
speeding up at like
increasing,
one-
so I would say I agree with that.
Yeah.
wait, what do you agree with?
I agree that after it's hit, it speeds up because
Well,
the
it
unbalanced
speeds up
force
like-
now is increased because you
doesn't
apply
keep
more force to
speeding.
the ball.
But you're not.
It's
you're not
changing direction also, but
I think
it's
it
also
only
speeding up.
changed.
Okay, hold on.
But then it's constant again. Once the unbalanced force is removed, it's constant again.
So it speeds up.
Yeah,
That's what I said.
Exactly.
Speeds up and then it stays the speed that it.
Yeah, that's what I'm
And
saying.
then.
I'm not saying it continues to speed up. I'm saying when the ruler hits the ball, it's sped up.
And then
That's what we
stays
said.
constant from there.
Okay, so
I don't know, it's hard to read. I'm confused.
you're confused.
It just
I'm
gets faster,
confused.
but it stays constant. It's not faster.
No, so this is important, but I think that there are a couple. I want to make sure that we're all in on the same language so that we can figure out what we're saying. So I'm going to repeat what I heard. So it's moving constantly, then it gets hit. The hit lasts for a very short moment, yes?
Yes.
After that, it's going at a new but constant speed.
Yes.
Yeah.
Yes.
Is that true?
Yeah.
While it was being hit, two things happened. I'm repeating. Brendan said, while it's being hit, it changed the direction and sped it up a little bit. That's what you said. Okay? So I want to make sure that if this is something that someone thinks, does your board represent that, and is this what you believe? Okay? It's going constant, it gets hit, during the hitting, it changes direction a little bit and speeds up a little bit,
But then it becomes constant again.
but then it's constant again after that. New speed, new direction.
Yep.
Is that true? Okay, check with your neighbors, see if that's what is represented on your board. Okay? See if that's represented on your board. I'm interested to know if that's true.
Yeah, everyone
Constant and
has,
then they're equal again.
well, yeah, everyone really
And
has
there's
the
only
same
acceleration
thing.
around that.
They're just going the wrong way.
I can't
Did you
do
hear that bird?
I learned how to.
I have
whistle.
no special talents.
That is false.
I think that's probably
I'm
false
good at
too.
Minecraft.
That's not bad. Well, I'm sure you also practice to get that way. Right?
Yeah,
Is that not true?
sure.
He's good at
All right.
I'm not.
Good at what?
He can run.
Running, cross country, no. I'm not.
Not good at it? Don't like it?
50% of the people.
All right, Charlie, show us your board. Sahid, are you buying what they're selling here?
Sahib is distracted.
Mine,
So-
So they said it's constant, then it gets hit. During the hitting, two things happen.
Yeah.
Okay? One, it changes direction, and two, it speeds up a little bit, and then you have a new constant speed after that.
Yeah.
I agree.
You agree? Does your board represent that?
I think so.
Yeah.
Yeah.
It does.
Show us.
Yeah, so it gets hit right here,
Yep.
and that's when it speeds up a little bit, and then it goes constant after that hit.
Okay? What's a natural tendency of an object of motion?
Stay in motion.
What kind?
Constant. Straight.
Good. Constant speed, straight line.
Yeah.
Unless what?
Balanced force.
Unbalanced force.
Absolutely. So,
We're good.
Girl, bye.
We got it.
you okay?
I switched hands.
Oh,
No.
switched hands and so I like this as a representation because it's going in a straight line at a constant speed. When the forces are unbalanced, what happens to it?
Change direction and speed.
It changes direction, doesn't it? So that, but then after that, it's constant speed again because the unbalanced force doesn't last very long.
Yeah.
So what is the point here then?
Unbalanced force matters.
It does, right? I actually think this is great because if you look at that, what does unbalanced force lead to?
Acceleration.
Now, up until now, we've only had two types of acceleration. What have they been?
Speeding up and slowing down.
Speeding up and slowing down. But all of a sudden, I mean, let's do the thing again, right? We have speeding up, here.
Speeding up.
We have speeding up, and we have slowing down, but that's if they're in the same direction or opposite directions. But what if they are
Changing direction.
Whoa.
perpendicular to one another, leads to a change in direction?
Yeah.
Yes.
Yeah.
So they stand.
So let's go back to our car example then. Traditionally, the gas pedal, the one on the far right, has been called the accelerator. Are there any other accelerators in your car?
Brake.
Check with your neighbor.
Yes, it's the brake.
I can't
Brake
drive.
is a decelerator.
The
But
decelerator.
it's
No way. That's insane.
I don't understand cars.
Do people drive?
Have not driven a car. so-
Somebody tried to
Car could
drive
have
at
a
10
wing.
feet. Like, is that like legal? Like,
So-
drive
illegal.
It's actually very
Like,
dangerous.
that's why cars have
Have you tried it?
No, because I know how to drive.
Have you?
I just wondered if anybody
But like the
cared.
Bugatti Chiron.
That's how you do donuts.
All right.
Cruise control.
Is the gas pedal,
That was him.
the cruise control literally keeps you at a constant speed.
Not
No, if you click the plus button.
Oh, and also sometimes if you like
So
go
then the
through
cruise
part
control
of
is
the
the
road that's like
constant
uneven or something, the speed shifts up and down a little bit.
Brake.
I once set it to like 25 and it went to like 24 for a split second. and went back.
A car could have a wing.
A wing?
Yeah, like a wing
You're
on
an
a car.
adrenaline junkie.
What does the wing do?
It slows it down.
Yeah,
But not like,
Um,
I would say the brake.
ask me tomorrow, I'll tell you what the wing does.
Doesn't the wing make it more aerodynamic?
yeah, that's what
No, it actually makes it less aerodynamic, but for a specific reason. It's actually something that we understand that we'll get.
What's a wing on
All right,
What's a wing on a car?
It's a downforce.
it is a downforce, yes.
What's a wing
Doesn't
on
it
a
make it have
car?
less wind resistance?
more
No.
resistance.
More.
More.
It keeps it lower to the ground, right?